Thank you. Good morning. Thank you so much for the warm welcome and the opportunity to speak here today. I really appreciate it. A colleague of mine, who is our chief scientist, named Jeff Hammerbacher, was on the Charlie Rose show recently, and he's in addition to being our chief scientist, he's at the Mount Sinai Hospital in New York at the Icahn School of Medicine, and he does data science with medical applications there. And Charlie was asking him about his experience and how he got into it. And Jeff was describing a trip to the doctor he had made a year or so ago, and said, he had this lump in his chest, and he went into the doctor, and the doctor felt around and said, I'm going to refer you to someone else. He then goes into the second doctor. Doctor puts his hands on his chest and feels around. And Jeff is a data scientist, started the data team at Facebook. And the whole time he's thinking to himself, don't you want to use some sort of measuring device or, actually quantify what's going on inside of my data? And he was contrasting this experience at the doctor with his experience at Facebook, where if they had a problem, affecting a service, they had more insight into, what an individual server at Facebook was doing than what the doctors had diagnosing a disease in his body. And that's not something that I think is going to be true, 5 to 10 years from now. Certainly not within 10 years, hopefully not within 5, right? The idea that we have more insight into a $1,000 computer than we do our own bodies. And I believe that for three reasons, really three trends that are starting to combine now to make data the center of new applications and to bring about a different world. And the first trend is just the sheer amount of data that we're producing. So you can't give a big data talk without referencing the fact that 90% of the world's data was created in the last 2 years. And the amount of data in the universe today is really just a function of how connected we are. And of course, we're more connected than we ever have been before, right? So it started with the internet and then smartphones. Now we're putting sensors on everything. Right, so like the seal here is one of thousands that's constantly reading data about the ocean, and we estimate that by 2025, or 10 years from now, there will be 100 billion sensors collecting data on the planet. Right, so that's more than 10 times the number of sensors collecting data than the number of human beings. Right. And so if you zoom out, what's going on is there's just tremendous instrumentation of life, right? We're just collecting a lot of data, not just in the services we build and the products we consume. All of our activities are generating data. And the reason is that we want to measure everything, right? So as scientists and data-centric people, we've always wanted to measure everything. And what's true now is that we actually have the capability to do so. And the result is that we're just swimming in data. And historically, we've lived in very data-poor times, but now we're living in very data-abundant times, right? So it used to be that computers were very precious, and now humans are precious and computers are cheap. So we're seeing a fundamental shift in terms of the relationship between humans and computers and technology. The second trend is that computing is just plummeting in price. So the economies of scale that are being driven by all the phones and the internet and all of that technology that we're consuming is really driving down costs. So you can just do incredible things for the fraction of the cost. So you all know, your smartphone in your pocket is more powerful than a high-performance computer from a decade ago. And this is, of course, related to the fact that we're generating all of this data. And the interesting part for application developers is that historically we've only used a fraction of the data that was accessible to us. And a metric I really like to use is called return on byte, or ROB here. And return on byte is just it's the value of a byte divided by the cost to store it. And so you can think the value of a piece of information is, right, all of the things that we can learn by analyzing it, combining it with other data sets. How much does this contribute to a better application? And the cost, of course, is just the cost to physically store it, serve it, analyze it, and so on. right? And the cost, of course, drops every year. And as we get more and more sophisticated algorithms and techniques, we can increase the value. So if you think about, what data is accessible, it's this ROB greater than 1 data that's above the waterline in the iceberg. And then anything that's below the waterline, this ROB less than 1 data, is data that we don't collect or we discard. That's really not accessible to the application. And so if the way I like to think about big data is we're trying to drain the water line here to really use make all of the data accessible to our applications. And people think when they talk about big data, they tend to focus on size, right? So if you look at the Oxford English Dictionary's definition of big data, it's data of a very large size, typically to the extent that its manipulation and management poses significant logistical challenges. And I don't actually think this is a great definition. And one of the reasons is it's not stable, right? So what might pose significant logistical challenges for you might not be for me, and so we can't really agree what big data is. And it also kind of misses the economics, right? It misses the iceberg. This is, I think, a better definition. It's from George Dyson, who is a science historian at the Long Now Foundation. And his definition of big data is what happened when the cost of storing information became less than the cost of the decision to throw it away. And so notice that he's focusing on cost instead of size. And what he's basically saying is that the cost of storing information is going so low, and the potential value, right, the opportunity cost of throwing it away is so high that effectively all data is becoming ROB greater than 1, right? So big data isn't just about, how big your database is. It's really about the ability to use all of the data to benefit an application. And we're starting to see that in the third trend, which is the democratization of analytics. So analytics is the systematic analysis of computational analysis of data, and our activities now generate data, as we pointed out, and increasingly our activities now consume data. So as that cycle has happened, we can start improving everything we do through the analysis of the data, and then baking that analysis into applications themselves. And a great example of this is how you book a flight today, right? So it used to be that the process of booking a flight was, I'm in St. Louis and I want to go to New York, so, from point A to point B, what are my options? I see some basic search results. And now you can say, well, what beach can I go to for $500 in 8 hours from where I am currently? Effectively, we all look like BI users from this perspective. And we don't even think about it, but we're consuming a tremendous amount of analytics that just went into creating the data behind this interface. And that's just scratching the surface. So the analytics is baked into the whole process. So if you think about the dynamic ticket pricing algorithm that went in to compute the various prices here, the fact that price actually will change, based on fuel and the time of the day and which airline and even your personal history if you've logged in. So pricing is dramatically different. All of the real-time ad auctions that took place to actually show you specific flights involve tremendous amounts of analytics. All of the targeted promotions, all the information based on consumer data that were used to promote different options. So there's just analytics dripping through the whole process here. And this is something that we do today, and it's already had a big impact on the industry. So, for example, this is a screenshot from Kayak, which is owned by Priceline.com. They spend $1 billion a year just on Google ads, and they do tremendous analysis just to figure out which ads they should consume. And Priceline.com is worth $60 billion, right? So the largest airline in the United States, the people who actually put airplanes and bodies in the sky and get you from point A to point B safely, the largest of those companies in the U.S. is worth half of Priceline. Right, so that just gives you a sense of how much analytics has really just impacted some of these very basic activities. Looking forward, a kind of a more forward-looking example of analytics, Google has been obviously a leader in big data, and they've been doing a lot of interesting work with deep learning. which is a branch of machine learning. So machine learning in general is already getting widely consumed, and for example, that travel example involves a ton of machine learning. And deep learning is a specific branch that's been making big strides. So in 2012, Google used 16,000 processors to build a computer vision and machine learning model that could detect cats, right? Which is, of course, very important on the internet given how many cat videos there are. And and they were very excited, right? We never told it during this training, this is a cat. It basically invented the concept of a cat, and it took 16,000 processors. 2 years later, this exact same computation was done on a PC with a nice GPU, right? That was a year ago. And you say, wow, recognizing cats is great, but how might this be actually applicable to, the real world of applications? And just like last week, some researchers published a really interesting result in pediatrics. And they developed a computer vision and machine learning model for detecting post-operative pain in children. And what's fascinating about their model is that they found that they could detect the presence of pain as well as a nurse, and they could detect the severity of pain as well as that child's parent. Now think about this. As a new father, I find this incredible, right? They've got an algorithm that can detect pain in my child as well as I can. And think about this. What could we do if there was an expensive, ubiquitous service that could just automatically measure pain? Right? Think about how that could transform applications. And this is built on a lot of the similar deep learning technology. And again, it's the type of thing that was previously inaccessible, but is getting more and more accessible every year. And in short, it's all about the data, right? This won't be surprising coming from me. But one of my favorite quotes is from W. Edward Deming, and he said, and he's showing, I think, the fact that he's a statistician. He said, "In God we trust, all others must bring data." And this is the kind of holy grail that we're trying to get to. And we've always wanted to be data-driven, but we increasingly now have the ability to be really data-driven, right? Because we now have the data, per that first trend, right? So because we're instrumenting everything, we can, we're getting information not just from all of these services, but from sensors and devices. We can afford to use it, so we can afford to collect, store, and analyze it. And our analysis capabilities are getting more and more sophisticated every year. And now we've also found a way to inject the value of that analysis into applications. And there are many examples of this. I think the airline example is a good one. Actually, your population health application, I think, is another great example of that. But that's really the macro trend, right? Is that we're figuring out how to push the value of the analysis of the data into applications, which will tremendously increase the consumption of analytics, right? So analytics won't just be a domain of the select few who have access to the data and expensive infrastructure. Analytics will just be something we all consume as part of doing our everyday activities. And the implication is big here, right? The implication is we have to figure out how to use data to build better applications, right? Data is no longer just the byproduct of a business process. Data is actually the core of an application. It's actually driving the new applications, right? And that's huge for application developers. And this isn't, as I mentioned, there are existing examples of this. This is really having a much bigger impact, even outside of the software industry. And this point was made really well by Mark Andreessen in 2011, and he posted this op-ed in the Wall Street Journal called "Software is Eating the World." And in that article, he talked about how there's a fundamental software-based transformation going on in industries where software companies are effectively taking over large swaths of the economy. So if look at marketing, media, telecommunications, financial services, transportation, and so on, there are billion-dollar software companies that are rethinking the way things are done, and data is really at the core of what they're doing, and they're rethinking the fundamental process of these industries with a data focus. And Aaron Levy, the founder and CEO of Box, which is an enterprise storage company, tweeted this, I think, last month, and he said, "Adding software to a broken process doesn't make you digital. The biggest challenge is reimagining the process, not writing the software." And so perhaps like some managers, maybe he's underestimating how hard it is to write software, right? Those of us who write software can appreciate that. But his main point, which is that you have to reimagine the process, really really holds. And so these companies are developing fundamentally new services. They're rethinking the process. They're data-enriched services. So let's look at some examples of that. One of my favorite is what Netflix has done with television. So how many of you watch House of Cards? Okay, that's about 40%. So apologies to the other 60%. You're missing out on one of the first data-driven television shows. And Netflix collects insane amounts of data as part of their service. So what you watch, when you watch it, how far along you get to watch it, what you watched after it. They have hundreds of metadata tags on all of their content, tone, genre, information about the actors, and so on. And so they've been collecting tremendous amounts of information about their service, and historically they've used that to recommend shows to you, so that if you like this show, they'll recommend maybe a more long-tail, obscure show that you might like as well. And so they've gone from shipping red envelopes to building a service that delivers content and trying to use data to optimize that process. And now they're actually using data to drive the content itself. So they actually use the analysis of their data to develop House of Cards, to figure out what type of show their audience might like, and then develop that type of show. Right? So House of Cards was something that they thought they knew with high probability would be popular before they made it. And they didn't just use data in the process of figuring out, how to make the show, who to cast. They used data in the entire promotional process. So if you liked Thelma and Louise, you saw a trailer of House of Cards that showed the strong female characters. And so the entire process, from producing to delivering to consuming the show, was fundamentally a data-driven process. And at Netflix, they talk about the fact that they have 30 million different versions of their application. And of course, data is what is driving all of those 30 million different versions. And so that's what I mean about a data service that's really, data is really the fundamental of an application, right? Data, if you first looked at Netflix, you said, oh, they're not a data company. They ship DVDs and envelopes around, right? And now they've used data to fundamentally change the way that content is consumed. Another great example of this is Walt Disney. They have been doing a major overhaul of the infrastructure in their theme parks. And if you've been to Disney World, in the last couple of years, you might have gotten a Magic Band. In fact, when you go to Disney World now, they send you one in the mail, so everyone should have one. And what they've been trying to do is take a lot of the personalization and customization from the online world and mobile world, and then bring it seamlessly into a physical in-park experience. And so this band has everything you need. It has photos, your hotel room, your tickets, money. You can purchase everything with it. And you can use it when you check into line, so it automatically updates this traffic statistics. They're using it for crowd management. So Disney World used to have huge lines at the main entrance because they get 8,000 to 10,000 guests every hour. Now there are no lines because they have the band. And so they get all of this information about how you use Disney World, and then they use that to make the experience better. So this quote is from the CEO. He said, "We just treated everybody as a giant blob of people. It was tough time to figure out who our customers were so we could better serve them and stop delivering this one-size-fits-all experience." Right? So fundamentally they're saying the only way that we deliver a good experience is by using the data about our business. And it's a fascinating example. They're just getting started in terms of the capabilities for the Magic Band. And what was one of the really interesting things is that they're rolling this out in Disney World in Asia, and they're not even going to use the band just because the penetration of smartphones is so high. They think they can do the whole thing seamlessly through smartphones. So I think the most interesting and maybe relevant part of this example is this is a company with a huge amount of tradition, right? You don't mess with Disney World. The experience of their customers and employees is hugely valuable to them. But they were able to take data and build applications that fundamentally changed how they operate the park and deliver it to customers, even in the physical world, right? So this is something that had been done forever in the online world, but they're able to seamlessly do this in the physical world. Another interesting example that's along similar lines is a project by the Michael J. Fox Foundation and Intel, and it's a project to attack Parkinson's disease. And Parkinson's disease is a very tough disease. It develops very slowly, right? So you have to constantly monitor it over long periods of time. And patients come in to see doctors really infrequently. And then when they come in, they only get to see their doctor for a very short period of time, right? So you don't get a lot of time for data collection. Most of the data is a log that the patients keep. And it's obviously a very subjective log because they're writing it down. And of course, you can't really log your data when you're sleeping. So even when you have patients trying to monitor themselves, they can only look at certain periods of time. So this has made Parkinson's one of the hardest diseases to tackle, and the president of the foundation was pointing out here that we really haven't fundamentally changed the way that we diagnose Parkinson's in 200 years, right? So what we were doing, before the automobile is pretty much what we're doing today, despite the fact that we walk around with supercomputers in our pockets, right? Which is, of course, broken, and they've built this new technology. They're using a wearable. It gets 300 measurements a second, and they can detect slowness of movement, sleep quality, tremors, and they collect all of this data in real time from the patients. It gets uploaded and anonymized and aggregated, and so the doctor can automatically see all of the data for a patient, 24/7. And it's objective measurements, right? This is data that they can use to compare from one patient to the next. It's not subjective. And then the anonymized data can actually be collected and shared, throughout the world. So researchers can see not just the data from one patient, they can see the data from all the patients. Right? So patients and doctors needed a better way to monitor the progression of the disease, and researchers need a better way to track the efficacy of their treatments. And so just wearing a simple watch is enough to completely change the way that we diagnose and evaluate Parkinson's disease. These people aren't the only ones attacking Parkinson's. There's another really interesting project by Max Little, who is a researcher at Aston and now MIT. And they built a fascinating service a couple of years ago where they realized that the fundamental things that cause tremors in your body also cause very slight changes in your vocal cords. And that if they used basic voice over IP technology plus pretty advanced voice processing and some cutting-edge machine learning algorithms, they could actually, given enough voice samples, detect Parkinson's just from a phone call. And again, Parkinson's is a very, very tough disease. So there are no biomarkers, so you can't do a simple blood test. And the really only good screening that we've had is an in-clinic neurologist test, which is expensive, and in fact, most people don't end up doing it because, again, Parkinson's is a disease that progresses for a long time. You might not even know you have it. In fact, it normally takes people quite a while to figure that out. And so by developing the service, it's a free service that you could call into, they could diagnose Parkinson's, and then they would, of course, collect all this data that they could use to develop their model to try to develop a better model for detecting Parkinson's. And what's interesting is that Max was recently on stage at Apple as part of the Apple Watch keynote because they've moved this application just from being a voice service to being a physical, to getting data about your physical presence as well. So they can get, how your posture, your gait, your balance is in addition to your voice data, as well as doing testing some basic hand-eye coordination, just as a function of you going about your everyday, right? So it's a fundamentally different way to diagnose Parkinson's with a machine learning kind of data-centric approach at its core. So it's a very interesting project, and you can see just in Parkinson's here, we're really starting to take a very data-centric approach to diagnosing the disease, such that you may even that might even happen automatically. So you can imagine making phone calls or just going about your business and learning a lot more and getting a lot more insight about your body than you do when you go to the doctor's office, which is pretty wild. And this takes us back to that Wall Street Journal article I mentioned by Mark Andreessen. And you may know Mark as he was one of the co-creators of Mosaic, which is the first widely used web browser, co-founder of Netscape, and now a venture capitalist. And in this article, he specifically calls out healthcare. So he said, healthcare, in my view, is next up for fundamental software-based transformation. This, of course, is not news to you guys at Cerner. You guys are leaders in the space of using data to improve healthcare outcomes. But there's still huge potential and a lot of possibility that we're really just starting to see with the technology that's on the horizon. And I love Cerner's vision of getting all of the world's healthcare data in one place. And I hope you found a little bit of inspiration in these examples today. Thank you so much.